Jai Hind and welcome to all. Myself Shiwani from Ajay Kumar Garg Engineering College, Ghaziabad, Department of Applied Science and Humanities. In continuation of previous lecture, Introduction and Classification, I will complete this part, introduction and this in this lecture. So, basically in this lecture we will continue this part. And to make these slides, I took the help of two books, Jan and Jen, Engineering Chemistry, and second by Shashi Chawla, and site www.nptel.ac.in. In previous lecture, I finished the topic classification on the basis of tacticity. Tacticity means basically stereoisomerism, and in this we find that the arrangement of polymer are of three ways. First is isotactic, second is syndio, and third is atactic. Now, I took the classification of polymer on the basis of monomers. So, on the basis of monomers, the polymers may be homopolymer or copolymer. Homopolymer means the monomers are of same type, means if one type of monomer, that is all the repeating units are same, then this is called homopolymer. For example, common example, polythene. So, in polythene we see that there is a repetition of ethene up to n. Yes. So, this is a type of homopolymer, and the tacticity basically it is used for the homopolymer. So, if examiner asks, then classify the homopolymer, or ask classify the polymer on the basis of stereochemistry, we explain the tacticity. Now, copolymer. Copolymer is also known as heteropolymer, and in this two type of monomers are there, that is AB such type. For example, nylon 6,6. In nylon 6,6 we know that the monomers are adipic acid, suppose this is A, and hexamethylene diamine. And suppose this is B. So, the nylon 6 is formed by combination of adipic acid and hexamethylene, and we get a structure like this, AB, 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 so on. So, this is a type of copolymer. Now, copolymer types. So, arrangement of A, B, it may be of many types. So, here we took the 4 types. So, 2 different monomers polymerize to give different arrangement or different type of copolymers. So, first type is random polymers. Random copolymer means if AB arrangement is random, that is it is not necessary that after B A will attach and then B. So, if the combination or we can say the polymerization of monomer is not fixed, it is not a fixed type, then it is called random polymer, like AB, then it may be BA, then AB, then BA, whatever. So, if the monomer add randomly, then it is a type of random copolymer. Alternate copolymer. Alternate means when the A and B, they are two polymers, when the A and B alternate in polymer chain, they are arranged in such like A, then definitely B will come, then A, then B, then A, then B. So, if the combination of monomer is such type, then it is called alternate copolymer. Third is block polymer, copolymer. So, here the large blocks of A units and then large blocks of B units combined. For example, in this we see this. So, here block of this type of monomer, then block of another type of monomer, and then again first type and then second type. So, this type of arrangement is called block copolymer. And here we see that random means black, then red, then black. If it is alternate, then here red should be there, but not there. So, it is random, and if in alternate manner, that it is alternating. Block means a group of A, then group of B, then A, then B. And last, it is graft copolymer. Now, graft copolymer, they are used in medical field, and the one common graft copolymer is dendrimer. Dendrimer means branching. So, if the polymer expand like a branch of tree like this, then this type of arrangement or this type of copolymer is called dendrimer. So, it is an example of graft. So, in this a group of, or we can say the block of any one monomer is attached at the branch of chain of another monomer. So, here we see the chain of A, and then a group or block of B, it is attached with A. Here we see that before this we can see here the chain is one type of monomer and another type of monomer, a group, a block, it is attached in branch. Here we see that this is a basically type of graft copolymer, where the homopolymer are at side chains, and here we see that one type of or simple chain there is it may be random, it may be alternate, and at the branch two another monomers are there. So, it is not a copolymer exactly, but we can say the different type of copolymer, they are attached and form the graft type. Now, next, classification of polymer on the basis of synthesis, and especially we took addition as well as condensation. So, first we took the addition polymerization. Addition, if we see the point of organic, so addition reaction means double or triple bond, it get convert into single or double bond by the addition of some group or some molecule. So, here the thing is same, that is for addition polymerization, the monomer must contain at least double bond, so that the addition reaction take place. So, addition polymerization means when the polymer chain grows through the simple addition of monomers, but we know that direct addition is not possible. It means for the addition polymerization, initiation is required, and for initiation we required initiator, and initiator it may be free radical, initiator it may be anionic, or initiator it may be cationic. Anionic means when the initiator contain negative charge, for example, OH minus, and cationic means when the attacking agent or initiator it contain plus charge, for example, H plus. And free radical, this type of initiator generally it is provide in presence of sunlight. So, to initiate this addition polymerization, initiator is required, and they have well defined steps, and since it is a basically formation of chain, so the steps are also similar to the steps of chain reaction, and in chain reaction there are 3 steps. First is initiation. So, its first step is also initiation, second is propagation, and third is termination. These are the well defined steps in chain reaction, and since the polymer is also a chain, so we took all these three steps. So, first step is initiation. Initiation means first initiator get formed, and then this initiator it attack on one monomer, that is double bond site, and then the monomer it will be ready in form of radical. Second step is propagation. Now, propagation is the monomer free radical. It may be monomer cation or anion, it depends on which type of initiator we used. So, monomer radical, then it interacts with another molecules, not alkane, another alkene molecules, and continue the process of chain growth. Since the propagation steps is not fixed, it means the value of n it varies. It may be 100, it may be 1000. So, the n varies, and that is why when we find the molecular weight, we always write average molecular weight instead of this exact molecular weight. And then third step is termination. Termination means whenever two free radicals come in contact with each other, then they form a covalent bond, and free radical it get released for further action. So, termination it may be due to, or basically in termination either combination will take place or disproportionation will take place. So, we will discuss these points. Suppose now the first question is which type of initiator should be used. Here I am taking the free radical initiation reaction, free radical mechanism. So, for free radical either peroxides, and generally benzoyl peroxide is used. So, either peroxide or AIBN is used. Now, the next first point is what is AIBN? AIBN is azo, bis, I, iso, B is butyl, N is nitrile. It is a type of dye. Azo means N double bond N, and N double bond N means dye. So, N double bond N, bis means groups, double group, that is dye. Butyl means the number of carbon should be 4. Iso means one carbon is attached with 2 CH3. Nitrile means CN, and since bis is there means we write the same group here. So, C, CH3, CH3, Cn. So, this is a very good free radical initiator, and in presence of sunlight it gave 2 CH3, CCH3, Cn radical and plus N2. And to simplify the further reaction or further mechanism, suppose this is R. So, instead to write this, we write R radical. If we take benzoyl peroxide means C6H5, we write the benzoyl peroxide is C6H5 COO whole twice, or we can say C6. Benzoyl means C6H5CO. Peroxide means remember one common peroxide H2O2, hydrogen peroxide, and when we say benzoyl means C6H5 whole twice O2, this. So, C6H5CO whole twice, in presence of sunlight it gave the 2 C6H5 radical. and suppose I write this radical in terms of x. So, there is x radical. Now, first step of initiation is complete, that is formation of free radical. If we take AIBN, then R radical, and if we take benzoyl peroxide, then it is suppose X radical. Now, in initiation, this free radical, it attack one monomer so that the monomer radical get formed. It means one X radical combined with double bond. So, at one side the X will attach, and on another side this radical get attached. So, what get formed? X CH2, since it is addition reaction, and X and radical this get attached. So, double bond convert into single. So, X CH2 CH2 radical. Now, the initiation step is complete. Another second step is propagation. Propagation means increase the chain length. For basically for example, polythene, it is used as a wrapping material as well as for storage material. It means the strength, toughness, heat resistance property, it depends on molecular weight of the polymer, and molecular weight it depends on the N. As the number of N increases, that is the intermolecular forces, force of attraction, it also increases, means the molecular, that is it become more tough, it become more heat resistant or etc. So, N may vary, and that is why it is very difficult to predict the exact molecular weight. So, to avoid this, we took the average molecular weight instead of exact molecular weight. So, if suppose the one question arises, why we took average molecular weight instead of exact molecular weight? So, the simple answer is, since in this in propagation step N is not fixed, it means the kinetic length of this polymer chain, it may vary. And the second point is, termination is not fixed. It may take place either by combination or disproportionation, and in both steps the N may vary. So, since the N is not fixed, so that is why we take average molecular weight. Okay. So, second step propagation, come to the point. Second step propagation means chain length increases on the basis of our requirement, that is CH2 CH2 N this. Okay. Now, third step is termination. Termination means stop the reaction either by combination or disproportionation. Let us take I took the complete reaction, and the suppose question is polymerization of, write the mechanism of polymerization of propene by using free radical initiator, and suppose this free radical initiator is benzoyl peroxide. Okay. So, it is clear that our monomer is propene. In benzoyl peroxide, I think it is clear that C6H5 radical get formed, and suppose I write this C6H5 radical as a R radical or X radical. Now, propene means 2 carbon at double bond, and total number of carbon is 3. Prop means 3 carbon. This is propene. When R radical, first step, this R radical, it attack one monomer, and at one side the R will attach, while on another side the radical get attached. So, suppose this R here and this radical here. So, R CH2 single bond CH CH3 radical. So, one monomer radical is ready. So, this is the initiation step. First is formation of R radical and then this. Now, second step is propagation. In propagation, N molecule, it depends on requirement or which type of we get chain. So, N molecule get attached in a similar way, means at one side this portion get attached and on another side this radical get attached and the chain get formed. So, what will be the R CH2 CH CH3 and then it add with another this like this, then again it add with another like this and radical or up to N, that is suppose this is N. So, here we can write N plus 1 if you have any confusion, N radical. Okay. This. Okay. Now, third step, this step is propagation. In third step, termination. Termination means either combination or disproportionation. Combination means this chain plus this chain with radical plus again any chain or this chain with radical, it get combined and form covalent bond and then radical it gets separate. Disproportionation means this chain and suppose here we write so here suppose R CH2 CH CH3 then CH2 CH3 suppose N and then CH2 CH CH3 radical. So, in disproportionation the R radical and this R radical it gets separate and this H it will come here. So, H and here double bond get formed. So, disproportionation means stop the reaction at this point. And since in both cases we see that the kinetic length is not same and that is why we take the average molecular weight. Now, next is condensation polymerization. I think it is clear that in addition double bond get convert into chain or through a single bond. Now, in condensation polymer means when the functional groups are present, then these functional group get combined and some byproduct get eliminated. Byproduct it may be alcohol, it may be H2O, it may be HCl or etc. Here we took the example of PET. PET is a type of ester. Why we take this? Polyethylene terephthalate, it is a ester and we know that ester is formed by combination of acid and alcohol. So, one we took the acid COOH and in second monomer we take the alcohol and when the polymerization get take place then water get liberate and ester get formed. And suppose instead of this terphthalic acid, examiner ask write the condensation polymer, draw the structure of condensation polymer of this and you forget this COH group, only benzoic acid and plus suppose this is with second we are taking the same alcohol. Now examiner asks this. So immediately we think that in this monomer only one functional group is there, and to act as a monomer it should be at least bifunctional. That is, this benzoic acid, it does not give the condensation reaction, because for condensation or for monomer at least two functional groups should be there. So, that is why we are taking terphthalic acid. Now, difference between addition and condensation. Suppose we took pointwise. First, in addition polymerization, multiple bond is required, that is double bond or triple bond is required, while in condensation functional groups are required because something get liberate. Addition polymerization is also known as chain growth polymerization, while condensation polymerization may be known as step growth polymerization. Now, we extend this multiple bond. So, here the direct addition take place, so nothing get liberate, while in condensation byproducts get liberate. The repeating units, that is monomers, they may be same or different, while in this case generally they are different. Addition polymerization reaction is fast, it required initiator and it contains well defined steps, while condensation polymerization is formed in gradual steps, no well defined steps, directly heating it in presence of acidic or basic medium is sufficient. There is very little change in molecular mass. We can say that the average molecular weight of addition polymer is exact multiple of molecular weight of monomer, because nothing get liberate, while in condensation something get liberate. So, we can say not exact multiple, or we can write the molecular mass of polymer increases throughout the reaction. In this generally thermoplastic products are formed, while in condensation hard, brittle, or we can say thermoplastic or thermosetting product get formed. Now, the example, so here add this, that initiator is required and well defined steps. Addition polymerization, any type of monomer which contain double bond, it form addition polymer. So, polythene, PVC, polystyrene, etc. While in condensation where the functional groups are there, so suppose nylon 6,6, polyester or etc. Now, next is classification on the basis of thermal quality or on the basis of temperature. Generally, one line I think in previous lecture I said that all plastics are polymers, but it is not necessary that all polymers are plastic. That is, polymers, they may be fibers, they may be elastomers, that is rubber, or plastics. So, here we can also say that on the basis of this plastic behavior, the polymer may be thermoplastic or thermosetting. Now, what is thermoplastic? Thermoplastic means if the chain thermoplastic means basically those type of polymer where the chains are bonded with or they are entangled or bonded with weak van der Waals forces. That is, in thermoplastic there is no cross linking, but when we heat this thermoplastic and because the bonding or the forces are weak van der Waals force, so that is why the chain can easily broken by heating. So, they can be molded in any desired or new shape. So, thermoplastics are those plastics which become soften on heating, but again on cooling they become hard. So, I think first one point which come behind this, no cross linking between the chains, because if cross linking is there, it will be very difficult to break the chain. So, it the basically soft melting, or we can say ki the chain broken is not easy. And second, it can be molded in any shape, so the change can be shaped. And third point is there, that is weak forces are this. Now, thermoplastics, they can be amorphous or crystalline. Now, amorphous, in amorphous we see that there are long chain, but there is no chemical bond, that is they are entangled with each other. It means the temperature at or above which it behaves or they become soft, then this temperature is called glass transition temperature, that is TG. So, this is basically there is no fixed arrangement and there are long chain, long molecules, and they are basically mixed with each other without any chemical bond. But if we took the second category, crystalline, 100% crystalline polymer is impossible. So, instead of this crystalline we can say semi crystalline. So, here we see that few parts are like amorphous, but in few portion they are arranged in a manner. It means if we took the amorphous area, the temperature will call TG, but if we took the crystalline area, then it is called TM. TM is the melting temperature, because crystalline it doesn't have any range, so directly they can be melt. So, it means in semi crystalline in both portion TG and TM can defined. So, TG is the temperature at or above which the polymer behaves or it becomes soft, and TM is the melting temperature. Now, next is, these are the points of thermoplastic. I think one point is clear, on heating becomes soft, while on cooling it become hard. And the second point is they are bonded with weak van der Waals forces, so they can be they can be basically molded in any desired shape. So, they can be reshaped, recycled or reused. The chains, they can be move around to form a different shape, so they are tough material. The bond this, and thermoplastic material keeps in new shape, that is reshape. And the example of thermoplastic material is which type of plastic? PVC, that is if linear structure is there generally, then this type of polymers are called thermoplastic. So, one point we may write that they have generally linear structure. Now, next is thermosetting. Thermosetting means set. It means in this polymer chain are bonded with a strong covalent bond, or we can say there is a strong force. So, on heating they doesn't become soft. So, remolding is not possible in this case. So, extensive cross linking formed by the covalent bond prevent chain moving relative to each other, and the bond between the chain are so strong, so they cannot be broken when it is heated. That means the thermosetting material, they can't be reshaped or recycled. And these polymer molecules consist of long chain, and which is this. Now, if we took the point solubility, take the point. So, solubility means thermoplastic polymers, since they are arranged in linear manner. So, most of the thermoplastic polymer are soluble in organic solvent, but thermosetting polymer, they are not soluble in solvent, and they are thermoplastic setting polymer are comparatively brittle, while the thermoplastic polymers are hard or tough. And example is very common example, bakelite, and we know that in 1907 the first synthetic polymer which was prepared by Beckelum, it was the Beckelite by phenol and formaldehyde. Now, if we took the on the basis of origin, so I think it is clear that on the basis of origin, the main they can be described as natural polymer as well as synthetic polymer. Natural polymer means those isolate from natural materials, and synthetic polymer means which are synthesized in laboratory. Natural polymers are biopolymers, natural rubber, starch, proteins, etc., while the synthetic polymers are all type of polymers which we used. But in between these, one another type is semi-synthetic polymer. That is, those type of polymers which are chemically modified, which are prepared by chemically modification of natural polymer, like cellulose acetate, like cellulose nitrate. In 1870, the American inventor Mr. J.W. Rahayat, they reacted the cellulose nitrate with camphor at high temperature and pressure, and then he got celluloid, and celluloid, it was the first plastic material, but it comes in which category? Semi synthetic material, because it is prepared by chemical modification of natural polymer, which is cellulose. So, there are few first synthetic, semi synthetic polymer, and which I took this side. Now, on the basis of chemical nature, they may be classified as organic or inorganic. Organic means the mainly carbon backbone is there, and inorganic means instead of carbon, sulfur, silicon, these bond linkage is there. So, both are synthetic polymer, and instead of carbon or with carbon, if the heteroatoms like oxygen, nitrogen is there, then it may be heteroorganic. We can write this heteroorganic polymer, like melamine resins, like polyurethane or etc. And all type of silicon rubber, it comes in inorganic polymer. Now, I finished this introduction and classification by these properties, and then drawbacks. So, due to these properties, polymers are indispensable in everyday life. Low density, higher molecules, high molecular weight molecules, low coefficient of friction, good corrosion resistance, good moldability. They are most of the non-toxic or safe. They have very good or we can say generally they are insulator, but few polymers, they have very good thermal property or electrical property, or they can conduct the electricity. They can be produced with close dimensional tolerance, they are cheap or economical, and they can be produced transparent or in any desired color. These are few mechanical properties. With comparison, if we compare the polymer with metals, so the polymers have these mechanical properties: tensile strength, compressive strength, shear strength, elongation and toughness. And if we compare the on the base of modulus, that is stress or strain ratio, and we know that polymers, they are of three types: elastomer, fiber and plastic. First, stress means force per area, and strain means when we apply the force, then change in distance with respect to original distance. And since the elastomer, if we apply a force, then we can stretch it 3 to 10 times. So, in case of elastomer, strain is very high, while the stress is less or minimum. While in case of fiber, we see that the stress, that is fiber, it can't be stretched. So, here generally we can write here fiber. So, here the strain is minimum, but the stress is high. And third is plastic. So, plastic has this type of property, that is some value of strain as well as stress. Now, limitations. There are few limitations. Some polymers are combustible. The properties are time dependent. So, and this property is called crimping, poor temperature resistance, poor tensile strength, or one we can add that all polymers are not eco-friendly. So, I finish this lecture here, and in third lecture we will discuss 3 elastomers and 3 fibers. Thank you.